Hi, I'm Miller Su. I've designed a household nuclear radiation detector, and today, let me walk you through this development journey. Nuclear accidents often trigger long-term public panic, especially for parents. Kids' bodies are far more sensitive to radiation, so the key challenge was turning complex scientific data into simple, actionable daily info that caregivers can actually use. Through secondary research, I uncovered four key insights. Scientific data eases radiation anxiety. People want both detection and protection functions. Families with kids prioritize safety most, and a shared platform builds trust. This guided our entire design direction. So based on these findings, I tried integrating nuclear radiation protection and detection into everyday items. Plates, spoons, raincoats, small containers, sort of things. In the end, I choose a spoon as a carrier. Next, I study the spoon shape, size, functions, and how user would interact with it. I picked prototype materials and made a test one. First prototype, highly malleable, cost-effective foam board, including three spoons, different shapes, and one base. Test on the spoon's food holding capacity and base simulate usage showed. Spoon, handle not too thick. In the second test, I focus on connecting the spoon without secondary pollution. I compare three methods: insert, clip, and twist, using everyday items. The insert method won. It is faster and easier to use. Then I test the material: 3D printing TPU, a soft plastic, and disposable plastic spoons. Both held sugar, but the spoon plastic stuck to sugar easily. So I settled on a reusable handle plus disposable plastic spoons. Next, I test handle shape. Oval and concave curved handles both felt good, but the concave one would only be gripped in the middle, bad for placing the screen, so over it was. Now, onto the functional parts. I bought a Geiger kit, Arduino, and an OLED screen to test their compatibility. I place a smoke detector, which has tiny radioactive elements, near the Geiger key. The red line flashed more often, proving good accuracy, but the line only showed frequency, no details. Then the Geiger tube broke, halting progress, but that told me two things. The tube needs a sturdy case, and this kit was too big for a spoon. So I bought a Geiger detector PCB from China Kits online. It is slim, small, and integrated, perfect for a spoon. I 3D printed a PLA shell for it and made TPU buttons. First test, moving the smoke detector close made readings jump, great accuracy. Then I demonstrate usage. Here is how it works. Long press the second button to turn it on. Once on, you see detection values. Short press to switch value types. Long press again to turn it out. But most number didn't mean much to me. I didn't know what they scored for. During testing, when I removed the smoke detector, values dropped slowly. Turns out the Geiger counter has a data delay. So for the interface, I use simple programs like save and caution required to avoid panic from confusing numbers. My final design has three parts. First, an insert type replaceable disposable spoon, plus a function handle. Inside, there is a Geiger-Müller tube, radiation sensor, a signal processing circuit board, and an OLED screen. The UI uses a cute pixel style with a black-yellow skin, each holding radiation symbols. Buttons are intuitive. Long press for power, short press to detect or view details. There is a waiting screen to ease anxiety, and the base for non-stop monitoring. The casing has three layers reinforced structure, soft plastic bottoms, and a bright OLED screen. The top has the spoon connector. The bottom, a Type-C port. The back has a metal shell with UI matching patterns. The whole structure is tailored to the PCB, making it super stable. Using it takes just 3 simple steps, and it fits right into daily feeding routines. The design feels both friendly and professional. That's it for my journey. Thank you for your watching.